Hello everyone. Let's talk about Delta Wye conversion. What this means specifically is this. In any part of the circuit, if you see a delta structure represented in blue here, you can always replace that delta structure with a Y structure represented in black, provided you choose your resistor values appropriately. To see why this works, let's recap what we learned about equivalent resistance. We said that if we have any circuit which consists only of resistors and the two wires coming out of it, like this, then if you connect any voltage V and measure the current going in, then the ratio, the voltage over current, will always be constant no matter what that V, the voltage V is. An interesting question here would be, why would V over I be constant for all voltages V? And as we talked about then, this is a consequence of our circuit being linear. That is, all the KVL and KCL equations which we use to solve circuits are linear equations. So as usual, our answer to questions like this will always be because linear. Then we said, if you look at the circuit on the right, V over I here will also be constant and it will always be equal to R EQ. So if we set Req to be equal to V over I on the left hand side, then the circuit inside the circle will behave exactly like this resistor Req here. That means if in any part of the circuit we see we pick a part of the circuit where two wires are coming out, and inside that part of the circuit there's only resistors, then we can replace the entire circuit in the circle with a single resistor Req measured like this. Okay, so effectively we are saying that any part of a circuit with only resistors and connected by two wires can be replaced by a single resistor. Why? Because linear. So let's see how this applies to a slightly more complicated scenario. So in this scenario, let's consider there's some part of a circuit which is made only of resistors, and there are three wires coming out of it. So in this case, we can make the following statement. Any part of a circuit with only resistors and connected by three wires can be replaced by three resistors. Again, you can ask the question why, and you guessed it, because linear. Okay, I will make a future video showing why linearity of the circuit implies this, but for now we will take that as granted. So if you want to replace a circuit inside the circle with three resistors, there are only two ways you can do that. One would be a Y structure, and the other would be a delta structure. So at this point, please pause the video and try to come up with some other way of connecting three resistors, and then convince yourself that these are the only two ways. Note that a delta circuit is a circuit which contains only resistors and has three wires coming out of it. That means you can replace a delta circuit with a Y circuit. And a Y circuit is a circuit consisting only of resistors and then three wires coming out of it. That means a Y circuit can be replaced by a delta circuit. When we say one of these circuits can be replaced by the other, what we are saying is these two circuits behave exactly the same way, provided we choose the right values. So what does that mean? Let's say we connect current sources I1 and I2 as shown on the left and measure the voltages V1 and V2 as shown. Then, if we connect the same current sources I1 and I2 on the right hand side and measure the voltages V1 and V2 on the right hand side, then these voltages V1 and V2 should be on the right, should be the same as the voltages V1 and V2 on the left. Let's set I1 as 1 ampere and I2 as 0 ampere on the left hand side. Then we can see that V2 will be equal to R3. Pause the video here and convince yourself that V2 is equal to R3 on the left. We can do the same thing on the right hand side. Set I1 as 1 ampere, I2 as 0 ampere. Then V2 will be equal to the resistance Ra times the current through the resistance Ra, which we can get by using the current division rule, which will be equal to Rb divided by Ra plus Rb plus Rc. Again, pause the video here and convince yourself that V2 will be given as such. And we also said the voltages should be same on the left and on the right. This means R3 should be equal to Ra Rb divided by Ra plus Rb plus Rc. If you notice in the formula for R3, then R3 can be expressed as the product of its adjacent resistors Ra Rb divided by the sum of all three resistors in the delta circuit. Then we can use the symmetry in the circuit to write down the formulas for other resistors. So that means for R2, we can say this will be equal to Ra Rc divided by Ra plus Rb plus Rc, and R1 will be equal to Rb Rc divided by Ra plus Rb plus Rc. I'm writing the formulas here again for convenience. So given a delta circuit, you can calculate the resistance values in the Y circuit. So together, these formulas represent a delta to Y conversion. Then what about Y to delta conversion? If I take the pairwise products of the resistors R1, R2, and R3, then I get the expressions as shown here. So pause the video here and make sure that you also get the same thing when you multiply these values. If I add the three equations, I get the equation as shown, cancelling out Ra plus Rb plus Rc on the numerator and the denominator, dividing by R1 on both sides, we get the expression for Ra. Then using symmetry, we can get the formulas for Rb and Rc. Now together, these three equations represent a Y to delta conversion. As a reading exercise, please go through example 3.11 in the textbook to look at an application of delta Y conversion.